So we're going to look at how we can examine an IPv4 address for its network part and for its host part. So when a router examines a data packet, it will only look at the network part to find the destination, and only when we get to the destination and a network does the host part become significant. So an IPv4 address is segmented into 4 different octets, and we will define our address. So for example, if this was a 1 and a 0, all zeros to here, that would be defined as 129. If we had a 0 and then a 1 and then all zeros and a 1, that would be defined as 65, and so on. And that would define our IP address. The thing that determines what part is defined with the network part is the subnet mask. Wherever we have 1s, we will define a network part, and wherever we have 0s, we define a host part. So a router will not examine the host part. That is only used for the last part of the journey. It will only examine the network parts, and in the subnet mask we define the network part with a 1 and the host part with a 0. So with the network part, we fill from the left outwards until we fill all the network places that we want. So if we have 1 here, then we have 1 to 8. A 1 and a 1 gives us 1 to 9. That's a 1 to 8 and a 64. 3 1s, 2 to 4. 4 1s to 40. Then we have 248, 252, 254 and 255. Difference of 1, difference of 2, 4, 8, 16, 32, 64, and so on. Okay, so that defines our subnet mask, and the network part is defined by the ones here. So what we'll do is we'll have a look at a challenge, and I've added in this IP address converter, so you can get that from here. And this is going to analyze our IP address in terms of the host part and the network part. And what we'll do is we'll bring up the first subnet challenge here. Okay, so the first one is to look at the number of bits inside this subnet mask. Okay, if we want, we can paste it in here. Then we can analyze it. Okay, so for this subnet mask, we can see here is the network part and here is the host part. So the number of bits in the host part, this is the host part, is 8, 16, 17, 18, 19, 20, 21. 21 bits are in the host part of that subnet mask. And now we're asked for this IP address. Let's try another one. So on this one we have 255, 254. So you can see in this case we have 8 bits here and then 7 bits for the subnet mask. So we're asked again for the host part, so that is 16, 17 bits. Now for this one. We can see now that we're looking for the network part. So in this case, this is 240, ends up with 4 1s. So that's 16 and 4 1s is 20. And let's try this one. So we can see there 255, 255, 255, and then 192 is 2 1s here. So we must determine the host part. So there are only 6 bits in the host part. So the answer is 6 here. Let's try this one. And so this time we're looking for the host part. And we have 8, 16, 17, 18 bits. Okay, so we might see a question such as this. So we can actually see quite quickly that this is 192, so that's that address there. Okay, so this is just showing some very basic subnetting for the host and the network part.